So when current is not flowing through the wire, okay, what happens? There's no magnetic field generated. And if there is no magnetic field generated, then the magnet always rests in the north-south direction. It will always rest in the north-south direction. If you remember the previous year magnetism little bit, if you remember a little bit of magnetism, when a magnet is freely suspended, it comes to rest always in the north-south direction. The same thing happens over here. Important is that since you cannot see a solid line inside the compass, this indicates that the wire is below the compass. Okay. So then what is this arrow mark? This arrow mark is the needle of the compass. Okay. This arrow mark is the needle of the compass, always pointing towards which direction? North. So that means when the scale is not given to me and I have to decide the scale. Scale means what? The geography in north-south direction. So that means this is north now. So because this side is north, so north here. Opposite to that will be south. Correct? So if this is north, this is south. That means I know this is north. Right? Behind me is south. Towards my right will be east and towards my left will be west. Correct? Towards my right will be this one, which is this downwards will be east and this will be west. Does anyone have any doubts with respect to the scale? Sometimes the scale is not given. You've got to decide with respect to the compass needle when the current is not flowing. Anybody has any doubts? Now let's say, so the current is flowing. We connect the key. So when we connect the key, current is flowing in this direction. Perfect. If current is flowing in this direction, sir, there should be a magnetic field produced. Why? This is what we have learned the very first when I started electricity. But let's say you didn't know that statement. Let's say we got to prove that statement. So when the current is flowing, when the circuit is connected now, when the current is flowing, we find out that there's a deflection in the compass. There's a deflection in the compass. Now, why is this compass deflecting? Compass can deflect only when there's a presence of magnetic field. Correct? Only when there's a presence of magnetic field, the compass can deflect, right? Now suddenly we see that the magnetic compass is deflecting. Because of this, we concluded, Oersted concluded that whenever current is flowing through the conductor and a compass is placed around it, okay, or whenever a current is flowing through the conductor, it will produce or generate a magnetic field. How can we conclude that there is a magnetic field generated? He showed by this experiment, his setup, by placing a magnetic compass. By placing a magnetic compass, he figured out that this magnetic field produced because there's a deflection in the compass, which I made you write in a little bit prior. Okay. So now how do I decide, sir, in which direction it is deflecting? Okay. So as per the Jugaad method, which we know, this is the direction. Current, make 3 columns. Current, wire, and deflection. I hope everyone knows why current is moving in this direction, because this is positive, this is negative. Current always flows from positive terminal to negative terminal, correct? Right? So now, when the current is flowing, so this was the needle, right? That means this is south and this is north. Yes or no? This is north and this is south. So current is flowing in which direction? South to north. Yes. And the wire is below or over?
Below.
Below. We are interested in the wire. We are not interested in the compass. Wire is below. So now let's go back to the snow rule. In snow rule, the current must flow from which direction? It must flow from south to north. Correct? Current must flow from south to north. So is the current flowing from south to north? Yes. That means let's assume this to be positive. The wire should be over. Is the wire over? No, it is below. That means it is negative. What is positive into negative? Negative. Correct. Had it been positive, what would be the deflection? West. Now, since it is negative, it will deflect in the eastwards. And where is east? It is, we have to show the deflection. Downwards like this. Here? Yes? Once again, repeating this entire thing. Guys. This is what you need to understand. Every day, there's just one concept going to be taught, and you got to learn the concept pretty carefully and do not miss the class. Also, at the same time, please see to that whatever has been taught in today's class, the questions, the examples that has been taken in today's class, immediately go back, sit with it for half an hour, 30, 40 minutes, 15 minutes, 1 hour, depends on your understanding. Okay. Sit with the same examples, try to figure out whether you are understanding the directions or not. Okay, do it in a separate sheet of paper and then try to find out the direction. Because the directions only carries mark, nothing else. So what is the entire answer? If such question generally pops in your board exam, writing this deflection is towards the east and showing this in the diagram, if diagram is asked, this carries 1 mark. This carries 1 mark, nothing else. So there's no, so these are jugaad method, which I am trying to put it across. This are not there in a textbook. Okay. It's just that we have found out a certain method that it becomes easier for you to understand. But otherwise, how is it done? It is done with the right hand thumb rule, Oersted's experiment. Okay. But this becomes easier to follow. So we put it across in this way. So now going ahead with once again, when the current was not flowing, the magnet was resting in the north-south direction. Correct? Because there is no magnetic field. When current is not flowing, there is no magnetic field. Result of which, what happens? Magnet always rests in the north-south direction. It is resting in the north-south direction. So when it is resting in the north-south direction, sometimes your geographic scale is not given. The scale is not given. So what you got to do? You got to find out the scale. In some questions it is directly given. In some questions it is not given. So you got to find this out. So we know that the arrow mark of the compass, when it is suspended freely, always points towards the north. So hence north is this direction. So I've mentioned here north. Opposite to that is south, downwards is east, and then west. I don't think there's an issue with finding out east and west. Okay. Now when suddenly, let's say now when we connect the plug and the current is now flowing through it. When the current is now flowing through it, what happens is this compass deflects eastwards. This compass deflects eastwards. Now when it is deflecting, what does it indicate? It is trying to indicate that there is a magnetic field produced. But why is it deflecting towards east? We have the jugaad method to find out the direction. Okay, that direction is very important. But why is it deflecting? The conclusion of the experiment, that is Oersted's experiment, stated that whenever current is flowing to the conductor, it will produce a magnetic field. The deflection gives me a confirmation stating that yes, current is flowing, magnetic field is generated, result of which this magnetic needle is getting deflected. Yeah. So now, how do I find out, sir, whether it is deflecting towards east or west? Now, question is another question generally people ask is, why isn't the needle getting deflected towards north or south? So it is already suspended freely in the north-south direction. So either it has to deflect towards east or towards west. It cannot again take a U-turn or something, no? Either it has to show that if there's a magnetic field, it will try to show eastwards or westwards, because it's already resting in a north-south direction. Now, if it is again trying to get deflected towards the north or towards the south, it makes no sense. So now to find this out in which direction it deflects, we use this method. But actually, which method do you use to find out the direction in Oersted's experiment? It is right hand thumb rule. Don't forget that. Don't just go in your exam and then write, because they ask what is Oersted's conclusion. That's nothing but when current is flowing through the conductor, magnetic field is generated. How do you conclude that? Because there's a deflection in the magnetic compass, whose direction is given by right hand thumb rule. Don't write snow rule and thumb, because if you write snow rule, even though you take binoculars and try to find out your marks, you will not find it. Okay. So here, current